So we saw the other day, okay, we have this equation here, okay, and ABC values are just values, like they're just numbers, okay? So when you see these equations, which you'll see down here, in the ABC spots, they're just numbers, okay? And this equation is what we call, it's one of the three forms of what we call a quadratic, which we saw was also called a okay. Remember, parabolas follow a shape like this or something. They just use, okay. So if we look at, or we work under those pretenses, okay, we have this like general equation, okay, and A, B, C are just going to be numbers, okay. We also saw the other day, and I'm going to show you how to find the Y-intercept from this, okay. So whatever the equation is, doesn't matter what it is, if it's written in this form, okay, you can always know the Y-intercept, or remember the Y-intercept is where the graph crosses the y-axis, okay? You can always find this value from C, which I'll show you in a second, okay? So the Y-intercept is found by looking at C. Whatever the C value is, that's the Y-intercept, and that's a point now, right? And remember, it took only about 3 points to figure out what a parabola was going to look like, okay? So we'll see. It'll make sense down here in a sec, okay? The other thing that we can find from this particular equation, when it's written like this, is whether or not the parabola is opening up or down, okay? That is determined by A. Okay, so if A is positive, we open up. And the opposite's true if it's negative. Okay, it opens down. Okay, so I'm giving you 3 questions here. We're going to take a look at them. Okay, and I'm going to prove to you why something is the way it is. Okay, particularly this Y-intercept. But we can start with the easy one for now. Okay, let's start with the direction of opening because I think that's a little bit easier. You can immediately look at this equation and tell me if it's opening up or down depending on the A value. The A value is always the number that's in front of the x squared. Okay? So, if I look at this equation, the number in front of x squared is 2. Okay? It's also not negative. It's positive, which means it's opening up. Okay? The next one we can see right off the top, it's negative. Negative 4. Down. The next one is also negative, so it also opens down. Okay? This is the easier of the 2 pieces of information. Right? And don't forget, if we scrolled up here and we looked at all the different kinds of information that we could find, like remember doing this, right? Look at all the stuff that we can find. This is a very small subset of what we can actually find with a parabola. Very small. Okay, so just keep that in mind too, right? When looking at this particular equation or this form of a parabola, there's a very small amount of information that we're able to find. It's not that it's useless, it's just a small amount of it, right? I can find these two things from this equation, okay? But there is lots of other information that we can find relative to a parabola. That's what the two other forms exist for. And that's what we're going to see as we move through here. I'm going to show you the other two forms. Okay? So I want you guys to prove to me, and I'll show you one anyway. Eventually, I want you guys to show me on your own what the y-intercept is going to be for each of these equations. Now, I've told you, if you look at C, C is the number that does not have an X on it, right? There's no X. These two here have an X on them. So I want you to show what the y-intercept is. Well, you can just trust the fact that I'm looking for the number that does not have the X. What's -3? Right? Which you could write as a point. Remember, it's always X and Y, 0, -3. Now, why is that the case? Why am I telling you that it's just the C value? Well, let's take a look here. Okay, if I take this equation, I'm going to write it down here. 2x squared plus 5x minus 3. If I look at a graph, okay, where x and y, a y-intercept occurs somewhere along here. Okay, where it is dependent on the equation, okay? But one thing is 100% true about that purple area, specifically the y-axis. Anywhere along this axis, the y-axis, no matter what, its x value is going to be 0, right? So it doesn't matter what point I pick along that vertical axis, the y-axis, or that purple highlighted section. It doesn't matter. If I pick this point, or this point, or this point, or this point, they're all going to start with they're all going to have 0 as the x value, and their y values change. Okay, that's what these are. -2, 1, 5, and 100. Okay, so with that being in mind, and I know the x value is equal to 0, and we call this an x-intercept, it's where it crosses the axis, right, whatever it's doing, then I can use what I showed you guys on last week. That's the equation. Well, if I know x has to equal 0 for a y-intercept, then you take x equals 0 and you plug it in here. Okay, and then you see what sort of result that you get out. Well, let's do that. Y equals 2. Squared means that you're multiplying a number by itself. So if it was 4 squared, it would be 4 times 4, which would equal 16. In this question, I'm plugging in 0 squared. 0 times 0 is still 0. Okay? Plus 5 times 0 minus 3. Well, 2 times 0 is 0. Plus 5 times 0 is 0 minus 3. So our answer is going to be y equals 0 minus 3. That's how we arrive at the fact that we're going to get a point 0, -3. That's why this works. Because it's where it's crossing this axis here. Right? And I'm just trying to find the number at which it's crossing. So instead of having to do this every single time, because it's redundant, after you've done it twice, we understand why it is the way it is. You can just look at the C value. You have to correctly identify the C value. Okay, so for this question, the next one, right? The C value is -8. So that means our y-intercept is going to be -8, 0, -8. Now, the third one is a little bit harder from the standpoint that you have a problem here. I see an A value, I see a B value, but there's no C value. So what's going on? I don't know. Well, remember, you can always rewrite something. Why can't you do this? That seems totally acceptable to me. Or if you're just adding nothing, then you haven't changed anything, right? Which means that the C value is 0. Okay, well, our y-intercept, therefore, is going to be 0, 0. Where is 0, 0? Well, on our grid, 0, 0 is right there, which means our y-intercept, our graph, is going to do something like this. Now, specific to this question, we also saw that it was supposed to open down. So in reality, when I go back down here, it's doing something like this in reality because we said it was opening down. Okay. If the A value had been positive, that's what it would look like. But because it's negative, it has to open down. Okay? Does anybody have any questions? I'm going to stop this here, and then we're going to move on to something else. Okay? So just if you have any questions about what's on this particular note from last week, I just wanted to clean that up because that's important. We need that. Okay? Because that's going to like set us up for the next part. Okay? So if you, all you're doing here is just plugging in, you're taking the X, the input, and you're plugging it in to both spots, and then you're getting a number out. That number goes here. You just do it. It's like a calculator exercise. You input the numbers, it spits out outputs, which are going to be the Y's, like a machine. You input things into a machine, you get something else out at the other end. Okay, that's something else is Y. Okay.